very quick overview of how Windows works and how Kubernetes on Windows works from a networking perspective. Okay, so first thing I'll do is come over here, kubectl get pods -a, right? So, you know, you can see I've got a whole bunch of pods running. Now we can look and see what their IP addresses are. Okay, so let me bring this in view. Yeah. Okay, so there we go. We can see I've got my pod network is in the 100 range here, right? And I've got several containers running, some on Windows and some on Linux, and they're all working from the same IP space. So that's great. Okay, so it works. Okay, so now the question winds up being, how does this all work? So if I get services, if I start a PowerShell command up, PowerShell terminal up, I'm already in the PowerShell terminal. So if I say get service OVS star, right? You'll see we get OVS DB server and OVS switchd, right? So those wind up coming into play over here. OVS winds up having a very sort of complicated interaction with the Windows operating system and with HNS, and it, I think, extends from HNS, and then Antrea kind of like programs OVS rules and so on and so forth. And HNS is the like Windows is like the Windows service that manages like the networking for each Windows container, which has a networking model similar to kind of like a VM compared with Kubernetes. For example, you can't do like host port type things in the same way that you can in regular Linux Kubernetes, and that's related to the fact that there's no actual privileged containers in Windows. So we're working towards that, and the reason we need that is because without that you have an architecture diagram that looks something like this, where your networking and your storage tend to actually have to go through the Windows operating system and then directly talk to these executable services that you're running. So as an example of how we do things today, if I do kubectl, if I actually want to go and look at my antrea agent, which is my CNI provider, you can see that actually all it really does is run a PowerShell command. Then, if I go and I actually want to go look at what that PowerShell command does, okay, that PowerShell command, and yeah, this guy right here, right, -n kube system. Okay, that PowerShell command. That's the wrong one. That PowerShell command is here, this antrea agent Windows, right? That one. Edit. This is a cm-n kube system is actually running a process called wins.exe. Okay, so wins is a rancher tool. It's a library that basically runs a host process, and then it allows you to on that host process, it allows you to then send that host process commands through a Windows pipe from a container, and because you mount the pipe into your Windows containers, and then those pipes then run commands on the host. Okay, so what's actually happening here is we are using Wins. We are running commands on the Windows host. Now, it turns out that actually storage works the same way, so it's not just a networking problem, but the CSI stack, and the way CSI actually works in Windows is you also essentially run a process on the host, and then through a pipe, through a Windows pipe, your storage providers, your CSI providers go and they make API, they tell this Windows pipe to run special, like specific PowerShell and other like OS level commands. So if I was to go into CMD or whatever, you can see that this is the CSI proxy, which is what you run if you're running a CSI on Windows right now. And if you look in here, you can see that, for example, there are these specific PowerShell commands that get run on the host. So rancher wins and CSI proxy are these two different ways of basically running commands on the host from a container by using this a pipe as a way that you backdoor commands. And so I've represented that here with this gray area. And mainly the purpose of this video is to kind of clarify and contextualize, at least for some of us in SIG Network who don't work on Windows, what the what the relative kind of importance of this is in terms of being able to have privileged containers on Windows and having a decent networking model for that. Because if we enable privileged containers on Windows, then the need for our storage layer and our CSI level to run processes that execute commands through this pipe sort of insecurely through this black box pipe that runs things on the host kind of goes away, and then each one of these different providers could provide low-level Windows sort of infrastructure services to our containers in the same way that we do daemon sets for regular Kubernetes Kubernetes processes. So, and just a quick, as you can see here, like when you're running a CNI in Windows, you have special agents for Linux, and then you have alternative agents for the Windows CNI. And that's pretty much it. That's really all I wanted to show you. There's one other thing that's interesting that's worth looking at, which is if you we're all used to doing this in Windows, which is we do the in Linux we always do this IP tables save, right? And then that gives us all of our IP tables rules that are made by the csiproxy. And if you do this in Windows, so there's no IP tables, right? But there is a similar command, and that's called netsh. And it turns out that if you look in the Kubernetes code base, right? So if I go to grep.app, and I look for netsh, and I go to kube, right? So I can see here that it's actually very heavily utilized, for example, in the Windows csiproxy, right? So netsh rules are essentially what our netsh rules are being written by the csiproxy in the same way that we normally would write IP tables rules. So netsh is, again, similar to IP tables, and like we can do netsh dump, and then we can look in here and we can see where our routing rules and all that stuff are being written. So that's like the other thing that, that's kind of the other analog for when you're kind of reasoning about these networking problems on Kube in Windows. So that's pretty much it. It's Jay, thanks.